So in this lesson, we want to take that general procedure, that general strategy that we had for unit conversion, which is called dimensional analysis. And we want to push it a little bit further. We're going to do a series of conversions that come in a chain. And very often when you're doing medication calculations, when you're trying to interpret a medical order in the health sciences, you have these kind of calculations to do. And your chances of getting them right are a lot higher if you can make a roadmap. And you are just not trying to randomly put things together, or you're not trying to just remember formulas. Instead, you're putting together a route that will take you from the information that you have to the information that you want. So keep that in mind when you're working through some of these more complicated unit conversion problems. And without writing down your plan before you start, your chances of getting the right answer are very low. So this thing I've been doing with writing down a roadmap is pretty important with more complicated problems. We're also going to see how to convert areas and volumes. And these usually involve powers of units. An area will involve squared length units, and a volume will be cubed length units. And it turns out that they are just as easy to do as any other conversion, but if you're converting from one cubed unit to another cubed unit, you have to cube the relationship that links them. Finally, we're going to look at how you relate masses with volumes. And the critical link in a problem like that, the link in your roadmap, the center of your roadmap, is going to be density. Density gives you mass per unit volume, so it links those two things. And look at the bigger picture while you're doing those questions. Things like density that have fractional units are always links between different things. For example, in the medical order problems, when they give you a dose rate, they'll tell you how many milligrams of drug you should administer per kilogram of patient. So that fraction, that dose rate, is giving you a connection between the body mass of the patient and the milligrams of drug, or the amount of drug that you're supposed to administer.